In this video, we will learn how to solve OR statement inequalities. A compound inequality is made up of two inequalities in one statement. There are three types of compound inequalities. An OR statement is the union of both inequalities, and we're looking for all the numbers that belong to either inequality. That means that if a number is being shaded by one of the inequalities, we will select it as part of our solution. An AND statement is an intersection of both inequalities. So we're looking for the numbers that belong to both inequalities. That means for a number to be part of the solution has to be shaded by both inequalities. And then we have the double inequality. That is a compound inequality that has this particular form. X will be between two values. So let's start example 6, and all of these will be OR statements. Remember, in an OR statement, we're looking for all the numbers that belong to either inequality. So let's begin. We will start by isolating the X on each of the inequalities separately. So let's try this one here. This is 2x minus 5 is greater than 3. To begin, we move anything that is being added or subtracted first. So I'm going to move this 5. We're going to add 5 to both sides of the inequality. That will leave us with, on the left side, 2x. The minus 5 plus 5 different signs we subtract. So 5 minus 5 will go to 0. We bring down the inequality, and on the right side, 3 plus 5 will give us 8. We are not done. We still need to move that 2 that is attached to x. Since it's multiplying, we're going to divide both sides of the inequality by 2. And on the left side, 2 divided by 2 will be 1, or 1x, or just x. Is greater than, on the right side, 8 divided by 2 will be 4. So then this inequality is asking us to shade all the numbers to the right side of 4, greater than 4, but they don't want us to include 4. So I'm going to do that. I'm going to locate the 4 in my number line, and I'm going to shade to the right of 4, not including the 4. We try it again with a second inequality. I'm going to move this 4 by subtracting 4 from both sides. On the left side, 4 minus 4 will go to 0, leaving me with negative x is greater than or equal to, well, 6 minus 4 will be 2. We are not done. We still need to get rid of that minus in front of the x, and we do that by dividing both sides by negative 1. So on the left side, the negative will turn that into a positive 1x, or just x. On the right side, 2 divided by negative 1 will be negative 2, but we have to be careful here. Since we divided by a negative, we have to remember that we flip that inequality. So this second inequality is asking us to shade everything to the left of negative 2. We want all the values that are less than, but this time less than or equal to negative 2. So we locate that negative 2 in the number line. We are going to include negative 2, and we're going to shade to the left side. On the left side, remember that is negative infinity, and on the right side, this is positive infinity. Because this is an OR statement, our solution will include every number that is shaded. In our case, if I read the number line from left to right, that is from negative infinity to negative 2, and then again from 4 to positive infinity. So let's write it down. From negative infinity to negative 2, and since I am including negative 2, the negative 2 will take a bracket. And remember, infinity always takes a parentheses. And then again from 4 to positive infinity, since we are not including the 4 will take parentheses, and so will infinity. Because our solution is broken in two pieces, what we're going to place between them to let the reader know that both pieces are part of the solution is to write a union. So then this is the solution for example 6a. Let's try another one. We're going to do 6b the same way. We're going to solve each inequality individually. graph it, and then see which values are being shaded by either one of those inequalities. So let's start with the first one. For the first, I'm going to subtract both sides by -1. On the left side, this will get eliminated, leaving me with -2x is less than or equal to -3 plus -1, same sign we add, that's -4. And then we're going to divide both sides by -2, being very careful. Since we dividing by a negative, we're going to have to flip that inequality. So -2 divided by -2, that's +1, 1x, or just x. On the right side, -4 divided by -2 will be +2, and we don't forget to flip that inequality. So this solution is telling us to go to 2, to shade everything that is greater than or equal to 2. So we do that. So I go to 2 and I shade everything that is greater than 2. And again, this is greater than or equal to, so I have to include that 2. So I place a square bracket. Great, let's go solve the second one. The first thing, we're going to move this 7, so -7, -7 on both sides of the inequality. From left to right, 7 minus 7 will go to 0, leaving me with 3x is greater than 4 minus 7, different signs. We subtract and keep the sign of the largest, so that's -3. And then we don't forget that we still have to divide both sides by 3. Being careful here, since I am dividing by a +3, I'm not going to flip this inequality. So on the left side, 3 divided by 3 is 1x, or just x. On the right side, -3 divided by 3, different signs. This will be a -1, and we keep the inequality. So this inequality states that we want every number greater than -1, but we are not including a -1. So in my number line, I go to -1 and I shade everything that is greater than -1. We're going towards positive infinity here, but we're not including -1, so we place a parenthesis. The reason we know that we are not including a -1 is because this inequality does not have the equal line. Okay. Again, because this is an OR statement, my solution will be any number that is shaded by either inequality. So looking at my number line from left to right, the first number that is start being shaded is from -1, and then it continues on to infinity. Notice how at a certain point the numbers are being shaded by both inequalities, and it really doesn't matter. We just want every number that is being shaded by either of the inequalities. So then my solution, again from left to right, will begin at -1, and it continues all the way towards positive infinity. Because we are not including that -1, it will take a parenthesis, and infinity always takes a parenthesis. So this is a single interval notation as a solution. We don't have to place the union. So this becomes the solution for 6b, and this was the solution for 6a. Let's try another example. For letter C, we begin again. So I'm going to add 12 to both sides from left to right. We have 2x, that goes to 0, is less than or equal to 8 plus 12, which is 20. Don't forget, we still need to divide by 2 both sides of the inequality. We are dividing by a +2, so we're not going to change the direction of that inequality. 2 divided by 2, that will be 1x, or just x. Bring down the inequality, and on the right side, 20 divided by 2 will be 10. Let's graph this. So I'm looking for every number that is less than or equal to 10. So I go to 10. I'm going to shade everything that is less than. That means that I'm going towards the left all the way to -infinity. But since I am including 10, I have to place a square bracket. Let's go solve our second inequality. For this one, we start by subtracting 8 from both sides. From left to right, I have an x. 8 minus 8 will get eliminated. Bring down the inequality, and -4 and -8 will become -12. Same sign, we add. This time, x doesn't have a coefficient for me to divide by, so then this is just x is greater than or equal to negative 12. So let's graph that. I'm looking for every number that is greater than or equal to negative 12. So I go to 12 and I'm going to shade everything greater than that. So I'm going to the right all the way to positive infinity, and I am including 12. So then that 12 is going to take a square bracket. So to find our solution, remember we read our number line from left to right. And what we're going to notice that going from left to right, every single number is being shaded. On the left side by the first inequality, and towards the right side by the second inequality, and in the middle by both. So because every single number is being shaded, that means that our solution is going to run all the way from negative infinity to positive infinity, and infinities always take parentheses. So then the thing to remember when we have an OR statement is that the solution will be all those numbers that are being shaded by either of the inequalities.
Thank you so much for watching, and I'll see you in the next one.